All right, Brendan, it is 11 o'clock. So if you want to go ahead and get started,
Okay.
you can get this workshop going.
Awesome. All right. Hello, everybody. My name is Brendan Coyne. I work for a company called Clear Creek Systems. I've been with Clear Creek for about 5 years. I have been in the industry approaching 20 years here, though. Prior to Clear Creek Systems, I worked for a company called Baker Tanks. And prior to that, I sold remediation systems for companies that had issues with pollution in their groundwater. I sold turnkey systems for that industry. I'm based in California, out of a Bay Area, Livermore office. I want to congratulate Stormwater Awareness Week. I think it's their 10-year anniversary, and I've been happy to be a part of that. I don't know, for maybe about 8 years on and off. I think this is maybe about my 5th or 6th presentation for one of their projects. So it's good to be back, and thank you for having us. Quick background on where I'm coming from here. This presentation is not necessarily commercial in nature. It's just meant to be, kind of a public service type thing. What we'd want to know if we were going to be putting in a treatment system for industrial stormwater. We specialize in providing solutions and the best fit technology. We don't supply a product per se. We're not locked in, never trying to sell you individual things, but a solution. Been in business that way since about 1994, and we have several offices along the West Coast. I mentioned I sit in the out of the Livermore office, and also Sacramento. It's where my home office is now, and we have an office now in Los Angeles, San Diego, for about 6 months now. So it's about our 6-month anniversary there. So I'll get into this. And one thing that I should say is that when I talk about we, it's not necessarily Clear Creek Systems. When I talk about we during this presentation, it's going to be we as stormwater professionals, okay? So I'll get going. We have today's presentation will be focusing on the design and implementation of an industrial stormwater treatment system. It's be a top-down review of how we as professionals approach these tasks. We'll touch on the following aspects: how to assess the site, including design and layout of the existing facility and future treatment, identifying any contaminants of concern, and we also will talk about how to treat stormwater efficiently and most economically. We'll talk about how we prove that out through pilot or bench testing. And then finally, I will touch on installation and post-installation considerations. That sound good? So the typical industrial stormwater approach, typical usually means all the time, but every site's going to be different. But they'll consist with of the following items. We'll want to meet with the client and their engineer and consultant. Some facilities elect to go it alone, and some have engineers or environmental consultants that assist them through the process. Oftentimes there could be some legal matters involved, and everybody's needs need to be met in that arena. So once we have the principles, we'll review any site information that we have. we'll take samples, conduct some bench testing, move on to preparing the budget, fabricate and install the equipment if we find that that's an economical way to approach the task. And then we'll also follow up with any support operations that may be needed in the future. Determining the best treatment solution for a facility is a process. There are a number of treatment options available, some less expensive than others. We find that we can arrive at the best approach by conducting the bench and pilot testing. And I'll go into that a little bit later. Follow through with the capital cost and O&M and the best fit technologies. But part of all that is having a good team, and that means our vendors, clients' engineers, their consultants, and facility management is key. We want to know going in, we want everybody to know that consistent permit compliance is possible. It's not something that you hope for. It's something you should be able to depend on. So the project preparation process will include a site walk and a site walk where we go through the site and look at actual conditions, look at housekeeping, how that may be playing a current role. Oftentimes housekeeping has already been picked up by the time we've been called in. B&Ps are in place, parking lots are being swept, metal has been put under cover. There's a number of B&Ps that can be followed. So we'll take a look at that, and we'll attempt to capture a sample of the stormwater or simulate a sample with fresh water in a problem area. From there, we'll create a site pollutant portfolio, perform bench testing, analyze percent reductions after our bench tests, and analyze all other obtained information, design and price a system. And I'll be going through each one of these items in the following slides. First, perform site walk, sample capture. We'll have our technical staff arrive at a facility, meet with the folks there, take that tour, and do an evaluation. We'll look at, again, the existing site conditions, the site pollutant sources. Where's this water coming? Where's the problem water coming from? And we'll initially look at the feasibility of treatment. Most often, again, we'll try to get 110 gallons worth of representative stormwater. That's like 255-gallon drums or half a tote. And we'll take that back to our laboratory or a laboratory and do the analysis and testing there. Once we get that laboratory analysis back, again, we as us as professionals will create a site pollutant portfolio. And what we'll be looking at is a whole list of different types of pollutants, and often they're associated with sources. So if we have cloudy water or high turbidity, a lot of times we can look at gravel lots or housekeeping, unswept lots. A lot of things can reduce turbidity or increase turbidity, I should say. We may have issues with pH. That could be affected by a number of different materials. And then also very, very often we'll see issues with copper and zinc. It's just out there. It's one of those things that everybody, a lot of people have to deal with. And then, decomposing organic material, anything on site like that, suspended solids. And finally, sometimes there's issues with VOCs and petroleum hydrocarbons and other legacy pollutants. So once we complete that task, we're going to have a summary of our pollutants of concern. And when we look at that, we are going to be looking at we'll be able to put together a unique site portfolio. We'll want to know what is the permitted pollutants levels that we need to stay under, and also what is not permitted. What are you not allowed to discharge from that site? We'll also look at other constituents that are going to be site specific, including any dissolved solids, metals, and also how big the particle sizes are in our water. This is an example of a site. We might find suspended solids at a level, copper, zinc, fecal coliform, and we'll also have some other pollutants of concern we might identify, dissolved solids or particulate solids. This example here with these constituents will kind of follow us through our step-by-step approach here. So we'll be able to see how we might treat for these on a theoretical site. Okay. So once we have that together, we'll perform our bench testing. So we'll know what the slate of pollutants looks like by now, and we have in the industry some knowledge that how to treat for those. Right. So we'll perform a bench testing and the pilot testing as needed. Things we'll do or look to do is remove the solids load. So any solids in the groundwater or the stormwater, we'll provide a mix. We'll test a mix of mechanical filtration techniques, and that might include sand filters or mixed media filters. We might need to add some chemical treatment and see how that reacts with that particular site's stormwater. And chemical is a scary word, but coagulants and flocculants aren't. So we'll typically use those types of words instead of chemicals. I'll talk a little bit more about coagulants, flocculants in the coming slides. Now, often we need to use a combination of the two, so both chemical and mechanical filtration. That won't remove everything oftentimes, though, unfortunately, and we need to remove ultrafine and dissolved loading off the stormwater. Usually this is stuff you can't see in the water. You could have reasonably clear water and still have some issues. So if that's the case, we typically will look towards adsorptive media, which can include a number of different medias. Most people are familiar with carbon. We use that to filter our drinking water, for example. But there's other medias too that are designed and successfully treat for every, not every metal, but a lot of metals that we'll find in our stormwater. Also, there's more exotic medias that we can move on to if needed. Those are called ion exchange resins. There's multiple proprietary blends. They are expensive. They do work though. They can, or they are designed to target individual components. So they're selected based on your existing problem. So one size does not fit all. On some of the more particular sites though, neither filtration and chemical treatment nor absorptive media or ion exchange work alone. Oftentimes it can be a combination of the two different types of systems used to clean your stormwater. We'll take two approaches to when we do our bench testing, and folks will usually want to do some qualitative testing. That would include jar testing, where we evaluate chemical treatment, determine the dose rates of any flocculant or coagulants that we might need to add to your system. And the qualitative is visual results only. We would be looking for clear water at that point. And then we'll also do some quantitative column testing, where we actually target the pollutants we know, solutions for each one of them. And that includes things like chemical treatment, mechanical filtration, and the absorptive treatment. Well, we talked about the chemical treatment, and I'm going to start calling it flocculant, or there's different types of flocks. Chitosan might be one of them. There are a number of different polymers that can be used. And, I want to call your attention to, to small particles floating around in that jar of water on the left. They can be so small that they can't be filtered out with mechanical means. The particles go right through the screens. They can go right through sand particles or bag filter elements. They're really small. Might not be able to see, but often they are negatively charged, and they pull in various constituents. And since they're all negatively charged, they stay suspended in that water. So in this case, you might have a negative charge pulling on a lead particle, copper particle, zinc, dirt, E. coli, could be anything there. But by adding a flocculant, which is selected, the flocculant is often a positively charged element that binds up all the negative elements together to create a larger sediment. That larger sediment will either drop out of solution, as I show in the left photo, or it can now be filtered out and through mechanical means and end up looking a lot better. As you'll see in the photo on the right, that water there has been sent through a filter after treatment with the flock. Hopefully that makes sense to everyone. Adsorptive media operates a lot differently, actually. The adsorbent media attracts particles as well, but it uses a lot of different forces, de Waals, capillary action. There's multiple different ways it works, but basically they pull in the particular particles, and they stick to the media or get absorbed into the media, and do not continue on in the process train. A typical lab may be set up similar to this. A working lab might look like that. You'll see the columns, indication of columns there, and other componentry. There's a photo of some work being done. You see how the flock has created a separation between the solids and the cloudy water at the top on the right. So once we finish all that up, we will want to analyze how well we did. And this is good data for consultants and people who anybody concerned with actual site, how the actual site might react with a treatment system. In this case, you'll want to look at the sample ID raw. That's your raw water samples. That's what we've collected in our at our site. In this case, there might be some chitosan enhanced sand filtration. That's the flocculant with a sand filter. We can immediately see some reduction in copper, total lead, some zinc, suspended solids, and the coliform. Now, what's good about that is that you're getting a big hit for the least amount of money. So this site looks pretty good as a candidate for sand filtration with some flocculant. In this case, we had two more lines under that, AM1, AM2. For our purposes today, we'll consider that absorptive media number 1 and another selection, absorptive media number 2. And we see that it didn't really have any effect on pH, although it did increase a little bit. Nothing on the NTUs. But we did see some results with AM2 for the copper, right? And also zinc was really good reduction there. No effect further on. And then in this instance, we consider the ion exchange media. We always abbreviate that, IX. A couple different ones. And, you know, while ion exchange is great, it's not for every site. And I don't really see any reason to suggest ion exchange media for the site. There is no hallmark to hang a hat on for that. And finally, UV. Sometimes UVs might be needed for the fecal coliform, but the sand filtration looks like it was able to take care of that. So no need for UV in this instance. So that's just kind of like an example of what you might look at after a bench test. And we should be able to make some decisions on what we would recommend as professionals to the client on a way to proceed. What's great about this type of thing is that it's defensible, it's repeatable, and oftentimes a third-party laboratory will do the final testing to check these levels. So very pro. So this is just a summary of that sheet. We'll be able to draw conclusions based on particulars. And in this case, we found that, or well, our example anyway, the particle load was too high for absorption alone, which means it was dirty water, and dissolved load too high for CSF alone. So I remember I talked about sometimes you need to use a combination of both technologies. This is one of those cases. All right. Finally, we'll analyze other information we obtained from the facility, and this helps us kind of put together the final plan that we will approach our clients together, along with consultants or engineers if they're part of it. But we want to look at outfalls. We want to know where that water is coming from. Is there a drainage off the top of the back end of the site, or coming in from your neighbors? We want to make sure that we're not treating somebody else's stormwater that's running on. The fertilizer plant next door can mess things up. So we'll be looking at things like that and site characteristics. We'll want to know where this water's going. Is it going right to the gutter? Do we have access to a storm drain? What's going on? We'll look at other things like, the dissolved solids in the fecal coliform. Where's that coming from? Can we clean that up? Why are the filters not able to work on this site? Is it because people are driving on them all day long and just pulverizing dirt and gravel? And lastly, but not leastly, you want to look at any other characteristics. Is there a new permit being issued by the permitting agency? We want to future-proof our solutions. A customer is going to spend a lot of money potentially on fixing this problem. They don't need to come back 2 or 3 years later and spend more money because somebody decided to enforce some other Clean Water Act or whatever might get changed as time goes on. So that's something that a point I would like to make is that the best solution is able to last. You can't foresee everything that might come down in the years to come, but consider how you might be able to add on to a system if you might need to at a certain point. People talk about new contaminants of concern that nobody heard of 5-10 years ago. PFAS, for example, might be an example of that. So if that came into play, would your system be able to handle that? Or would you have to go buy a whole new setup? So these are the types of things that we would look at too, and talk with as professionals with our team that we have coming to the table here. Finally, we'll want to design and price out the system. Now, the design's fun, the price isn't always fun. So how we do that, we want to determine the flow rates of the individual drainage basins if there's multiple flows coming. Often that is a direct correlation to site acreage and rainstorm events. So through tables, we can identify a design capability in terms of flow rates. Can we have a centralized treatment system? That means, is this site so big that we cannot combine flows into a single flow? Do we need to have 2 systems?
Email.
I don't know if that was a question or somebody's off mute. So sometimes we'll have a facility that spans across a city street. So they have operations on one side of the street, operations on another side of the street. Might need 2 systems. Maybe they can centralize the collection. So we'll talk about that. We'll determine what chemical treatment will best work if needed. That could be chitosan in our previous example. Determine absorptive media if needed. And that's going to be a mix of organoclay and carbon in our example. And finally, we'll size all the equipment appropriately. That means the pumps, the filter size. Any absorptive media is going to need some contact time. So how much media is going to be needed. And of course, all that comes with a price, right? So we need to be as economical as we can, because not everybody has open pocketbooks, unfortunately. Finally, or maybe not finally yet, but we also need to look at ancillary pricing for the client. And that could be things like infrastructure needs, stormwater vaults. Do they need to do anything else at the facility to clear an area for a treatment system? Do they have footprint available? These are other things. Do they need to have electricity brought in to power the 20 horsepower pump that they need for their 750 gallon per minute stormwater system? These are the other pricing needs that need to be addressed to provide a full picture to the client for consideration. And then finally, once all that is approved, there's definitely going to be some additional work done when the system goes in, and so that's what we'd be working towards. In our example that I'm using today, things that we would probably consider or need to look at: can we use the existing detention basin or stormwater vaults for storage? How much volume is in there? It counts. Need to know. More storage, the less treatment, or the lower treatment volume we'll have to have. We'll put together. We'll need to pump from the vaults to the centralized treatment, so pumps, and then we'll have to have some conveyance piping. If we have pumps, we'll have to have electrical run over to where the pump is. Can't have trucks running over extension cords, so a lot of times there's some trenching involved. We'll look at other things, like in this case, we'll have our chitosan pre-treatment ahead of a storage, so we can get some settling. And then from storage through the sand filter, some conveyance piping. And then finally, the absorption after the sand filter. We saw that work in our example. And then finally, we want a direct discharge to our designated area. Maybe this looks a little bit more, or a little bit easier to read, but we'll see our vaults, stormwater vaults or detention basins, pre-treatment with our flocculant. That's that chemical treatment I spoke about. Need some reaction time. It might take several minutes or even more sometimes for the sediments to drop out and clump together. And that needs to be designed in. Finally, that mechanical filtration, that could be the sand filter, and then the absorptive media, and finally discharge. So that's what it looks like in a line drawing. And that's what it looks like in practice. It could be configured a number of different ways. In this case, there is an above ground tank that the customer wanted. That could be all put underground. That could be in poly tanks, which is more often what we see. The absorptive media is in those red tanks, and the particle filtration is on the opposite side of this photo, but give you an idea of what a footprint looks like. You should be able to adapt the footprint to fit in corners or in certain areas. There's no hard and fast footprint requirement, but it needs to be considered as we install. Often we'd like to see everything on a nice pad as well. Just some additional thoughts to that kind of as a summary here. So we want to reduce the TSS load, reduce any dissolved metals. We chose a technology in this case because hardness wasn't a problem. We were able to get a small footprint in because we just had a single treatment point, which also results in the lower cost. We feel that based on our bench tests and all the data we've collected, that it's robust, and we've been able to prove to the proof of concept through our bench testing. So, couple looks at what that particular system might look like in terms of capital costs. 2016, which seems like forever ago now, just yesterday for me in a way. But prices have gone up since 2016. But back then, what you just saw, these are the numbers. One thing that needs to be considered is ongoing operation and maintenance. These things are not refrigerators. They do need to be checked on during the stormwater season. Client needs to consider whether they want to train a team to do that themselves, or have a consultant technician do it, or have the equipment provider potentially do that as well. These are all things that need to be determined. And in summary here, thanks for everybody for sticking with me. Each facility has their very unique challenges. There's no cookie cutter approach to this. Consider the client regulatory customer, the client, if you're a consultant or engineer, and regulatory needs, obviously. Assess the site, design and layout from A to Z. Identify the contaminants of concern. Figure out how to treat the water efficiently, and economically. You don't need the most expensive option. Pilot test, bench test those results. Consider installation and post-installation. How's that look? Includes operations and maintenance and ongoing needs, and what that all costs. All comes with a number. Does anybody have any questions at the moment? Just unmute yourself if you can. I'll have one more opportunity at the end. We're getting there though. I did want to take 5 minutes allowed to talk about Clear Creek systems. This will be the commercial portion of this. We're given like 5 minutes, but I don't think I'll take that long. But we provide site-specific solutions. Again, not a cookie cutter approach. We may not always be everything, have everything that you need in-house, and we don't even try to sell a particular product. Okay, What we do is provide solutions, all right? And that's where we make our mark, all right? We have a proven track record. Again, we do bench testing in our facilities. Sometimes we might not do it at our own facility, and it just depends on the particular site needs and what we're analyzing for. We keep an eye on robust and future-proof systems. I talked about that a little bit in the presentation. Future-proofing is very important. Long-term reliability. I mean, we're a pretty busy company. We can't afford to go address systems that are breaking down all the time. So it's to our benefit the more reliable system we produce, and that's what we keep that in mind when we put systems together for folks. And we don't need no operations manager at the plating facility wants to worry about this stuff. They want to plate metal, okay? So we keep that in mind too, with their needs for limited oversight of their system. We do have local support available all over. We're in California here in the West, but we also have other offices. And then one other thing that folks might not consider right away, but we would consider as part of our process, is that we also rent systems out. So we have a huge rental fleet of everything from RO systems, reverse osmosis systems, to absorptive media chains and UV systems, centrifuges, anything solid separation, we do rent out. Example of types of products, treatment technologies we regularly look at and what they work for. This presentation, I believe, will be archived on the Stormwater Awareness site. So if you need to refer to this, feel free. But just to give you an idea of what our internal capabilities are, we have data sets on all these types of issues, solids, turbidity, et cetera, that we draw from. And kind of give you a little idea in this little table what works best for different problem areas. Variety of industries. I mean, industrial stormwater just encompasses a lot of different areas. Okay, these are just some of them, or probably an extensive list, a general list, but shipyards, anyone dealing with soils or gravel, petroleum, chemical companies. Oftentimes there's some remediation that goes into that. Timber and wood facilities. These are all areas where we concentrate on, and probably everybody on this call is familiar with at least one or more of these areas. Yeah, I mentioned we have a lot of experience. This is just a little data set. This little partial list of facilities. Looks like, yeah, they are not made to be anonymous, but I took the Northwest, Pacific Northwest experience table just to see. Again, this will all be on archived on the Stormwater website. And almost done. Everything we do, so everything we talked about already is what we do this. We're not the only company that does this. I would say that most companies that provide stormwater treatment systems will do all these types of things, us included. And again, just our different technologies. So this is not an exhaustive list, but I just want to give you all an idea of what people look at for some pretty exotic treatment. And that's all I got for you. I'll give this presentation again to anybody that needs it. If you want any brown bag presentations, I'll be happy to do that. I can tailor make it to an individual site facility. So if you want us to present to your customer, I'm happy to do that. If you want us to present to your water district office, we can do that. Whatever I can do to be of any assistance, either me or one of my colleagues would be happy to do it. So, all right. Any other questions, folks, or any questions?
Awesome. Well, thank you, Brendan. And while we wait and see if there's any questions that pop up in the chat, thank you so much for sharing. This is really helpful. And yes, this will be recorded and posted on our website within 24 hours. So you'll be able to rewatch it or share it with anyone that you would like. And there are more workshops coming up today. We have one at 12:30 about conditioning construction projects. We have one at 1:45 about, in a COVID world, using a Literati app for cleanup events and getting municipalities involved in education outreach in this current time of the pandemic. And then we also have common mistakes and misconceptions associated with compost-based B&P applications, and that is at 3 p.m. So you can find all of those on our website, which is stormwaterawareness.org. All righty. Well, looks like we don't have any questions. So thank you, Brendan.
All right, thanks, Rebecca. I appreciate the work you guys do. Okay.
Awesome.
All right. Thanks, everybody.